All right, so for this one today, it's division of complex numbers. And the reason we kind of paused yesterday where we were is that division is really actually going to be multiplication. Just like if you do division with fractions, you don't really do division. You really just do keep, change, flip, and you make it multiplication. And this one's kind of along those same lines. Okay, so let's just kind of show you. And there's basically two different types of division problems that we're going to look at. Okay, so it looks something kind of like this. Okay, so there's your division of complex numbers. And we'll show you one in a minute where it looks a little bit different, but it's always kind of along those same lines. The big deal is with this one is that you cannot have your I variable in the denominator. Okay, just kind of a little thing that they like, especially if you're going to start working with fractions. It's hard to work with imaginary numbers in the denominator. It's hard to add, subtract, and multiply and do all the other things we have to do with it. So in this case, what they're going to do is they're going to say, all right, we need it so we've got an actual real number on the bottom. So what we're going to do, so to eliminate the I in the variable in the denominator, you're going to multiply the fraction by the conjugate of the denominator. Okay, and that's kind of where we paused yesterday because the last thing we did was getting the conjugate of the denominator and then going back and multiplying everything through with it. So for this particular problem, all right, we're going to multiply by, instead of 2 minus 5i, we're going to multiply by 2 plus 5i. And because it's a fraction, to keep it equal, if you do something on the bottom, you've got to do that exact same thing on the top with it. Okay. So top part. Now the top part, there is no real shortcut for the top part of this one because basically what we're going to wind up doing is just doing the full method for this part. So we can think about this being in parentheses when we're doing this. So it's 3 times 2 for 6. It's 3 times 5i for 15i. It's 4i times 2. And then it's 4i times 5i, which is 20i squared. Okay, and what we'll do before we get to the denominator, we'll go ahead and work on cleaning up the numerator. The 6 is good. You've got 15 plus 8, so that is 23i. And with the I squared again, that's where we're going to make the negative 1 substitution. That's 20 times negative 1, which will make that negative 20. So then we've got 6 minus 20, which would be negative 14, and then we've got the 23i. Okay, so sometimes, especially numerator-wise, it may or may not go quickly. It just kind of depends on the numbers. In this case, there was a full method, and we just had to go through and work that part out and simplify it. So not really anything short we could do for that part. All right, now, but here's the thing. When you're doing the denominator, you always will get a shortcut because what we were saying yesterday, that if we multiplied something by its conjugate, the part is that it would basically, if we were going to do the full method on the bottom, that as long as these are conjugates, the O's and the I's just cancel each other out. So the shortcut is it's going to be 2 times 2, which is 4. and then minus 5 times 5, which would be 25 I squared. Okay, and that's the whole reason that we do this with the denominators, that we get a conjugate shortcut on the denominator. If you replace the I squared with -1, that makes that on the bottom for plus 25. Because again, we're taking out the I squared to replace it with -1, which means on the bottom, this is just going to be over 29. And yes, every time you do that, when you have a denominator like this, you always use that conjugate shortcut. And they actually tell you, all right, if you're okay with that one, and you do a couple of these, then the shortcut really just becomes, it's going to be the first term squared plus the second term squared, if you look at just the numbers on it. Because it's always going to be that this is a positive times a negative, which you get that a negative, but that's always going to be I squared, which means you're going to replace that with -1. So that's always going to be a plus. So they even kind of go one step further and say, all right, well, if you're going to do this with conjugates and imaginary numbers, if we scratched out the O and the I and we had just the F and the L part of the full method to get us to here. But again, if it's conjugates and imaginary numbers, you can actually just go ahead and do a plus in between it and get it there. Now, it's great if you do that. If you don't, if you still want to kind of do what we did here and then go there, it's not that big a deal. It's an extra 3 seconds, which is not a huge shortcut. So I would say, if you don't want to worry about it, that's fine. Okay, and now the one thing you do want to do, and it's kind of hit and miss on Math Excel. If we're doing this on a test and it's written out where it's paper pencil, I'm okay with this answer. The only thing you have to be careful of is that if this is over 29, technically you've got to have it broken up so that you can see that if you could simplify this part or this part, you could. But if it doesn't simplify, then, it doesn't simplify. Then you would just leave it like that. So if it doesn't simplify, I'm okay with this on the test. Honestly, in Math Excel, sometimes they'll take this answer and sometimes they'll tell you, well, you've got the right numbers, it's just not written in the correct format, and you may have to go to this one. So honestly, I would say on Math Excel, I would view an example first and just see how they have the answer written so that when you get to the end, you'll know if the answer needs to be written like this or if it needs to be written like that. But again, test-wise, I'm okay either way, whichever one we go to there. All right, let's give you another one of those. This one will be a little bit shorter. So if that was example 1, back up here for this one, we'll go example 2. All right, let's go with 4 over 7 plus I. All right, so again, we're going to multiply by the conjugate, which would be 7 minus I. And again, just have to remember that when we do that, technically all these binomials are written with parentheses around them. So that's 4 times 7 for 28. 4 times I for 4I. On the bottom, again, we're going to do the conjugate shortcut, so it's going to be 7 times 7 for 49 minus I squared. But again, we'll replace I squared with -1, so it really makes it 49 plus 1. So that means that's going to be over 50. And that's going to be off the edge. Let me put that back down here so you can see it. All right, now, again, if you leave it like this, that would be wrong because there's a lot you can simplify on this one. You've got 28 over 50 minus 4I over 50. So you can simplify this one, divide both of them by 2, make it what, 20 or 14 over 25. Divide this one by 2 and make it 2 over 25. All right, and you also could do, and again, I think they might let you do this one as well. You might could just, because it's the same number on the bottom for both of these, you could write it like that. I would say safer bet is to leave it like this. But if you did leave it like this, that would be okay too. I'll take either one there. Okay, now the only one that you don't necessarily have to do a conjugate on for a denominator would be one where you had something like this, where it was like 6 minus 2i over 3i. Because one like that, all you have to do really is you're trying to get rid of the I in the denominator. So if it's just and the big difference is if it's a binomial in the denominator, you've got to do the conjugate. If it's one like this, where it's just an expression like this, you could do it one of a couple of different ways. Some people may say, well, if that's a positive 3i, I'll just multiply both of these by negative 3i, which would work. But again, the main thing is that for one like this, if you just got to get rid of the I in the denominator, you could just basically just multiply top and bottom by I. Again, if you did negative 3i on both, that would be fine too. So this case, as long as you've got just an I in the denominator, it doesn't really matter for this one. All right, so that's 6i minus 2i squared over 3i squared. All right, if we clean this up a little bit, we've got 6i. Take out both of the I squareds, replace them with negative 1. So that's 6i plus 2 over negative 3. All right, right back in a plus bi form, it's 2 plus 6i, reversing those two. Now, in this case, we cannot do anything with this over negative 3, but you can simplify that part. So this basically is negative 2/3 and then minus 2i. So just depending on the numbers and how it sets up, again, sometimes you may have one part that's a fraction, one part that's not, but you still just break it down and simplify it as much as you can as you go through those. Okay, so there's everything division. And again, it's basically just getting rid of the I variable. If it's just a single term in the denominator, you can just multiply it by I every time when you go through this one. If it's a binomial, if there's two terms in the denominator, you have to multiply by the conjugate. But again, on the denominator, you at least get the conjugate shortcut. Sometimes the numerator is not bad, just depends on the numbers and how it's set up there. Okay, now here's where we get just a bunch of just random little things that they throw at you at the back end of this one. All right, they may ask you to factor. And again, this is all still in that section with complex numbers. So you can basically imagine that for this one, you're going to have to use and this is probably one of those cases where they would probably tell you, leave your answer in complex form or use I in your answer. They'll probably give you some kind of hint on this and let you know, okay, this is not just a regular factoring in this case. Okay, because if you go back to your factoring rules, I don't have my blue sheet in front of me that we were factoring with, that if this was a difference of perfect squares, we can make this x plus 9, x minus 9. Again, if it was this, if it was a difference of the two, we can make it x plus 9 and then x minus 9. Okay, but this one's a plus, and we said if it was plus, there wasn't anything we could do to factor this one. But with imaginary numbers, now we've got a little bit of something that we can do here. So if it's a plus sign in the middle, we're still going to think that this is x times x. We're still going to think that this is 9 times 9. And the only way that's going to really be different from this part with the minus in the middle We're still going to do the plus 9. We're still going to do the minus 9. All you have to do different is just put an I with that second number. So last test, we had difference of perfect squares. You did plus minus 9. Now, if it's a positive in the middle, we're still going to do plus minus 9, but it's imaginary, so now we're going to have an I that goes with that one. Which makes it pretty easy. So no matter what the number is, if it's x squared plus 64, well, that's just going to be x plus 8i and then x minus 8i. Okay. And hopefully that's not too. Now, and then they turn around and take that and say, all right, well, now what happens if we solve something like that? Let's say we're going to solve x squared plus 100 equals 0. Well, if they tell you to solve by factoring, then this would be, x plus 10i and x minus 10i equals 0. And if you set both of those equal to 0, then you get x equals negative 10i, and you also get x equals a positive 10i. Now, was anybody thinking, and again, it basically worked out the same way. Was anybody thinking for this one, all right, let's just move the 100 over here to the right-hand side, and then we'll square root both sides? Was anybody thinking that? Yeah, that would work too, because you still get the same answer either way, right? You're still going to do the square root of a negative 100, which still means you're going to have positive or negative 10i. So, either way you go with that one, that's fine. They usually try to tie this one in with the factoring part, but I mean, we did the same thing in the beginning where we were solving this one by just square root both sides. So you could kind of go either way and be fine for that one. Okay, and then the last thing they kind of throw at you is where they're going to ask you to simplify. And they give you numbers that's imaginary, but it's just not quite written that way. Oh, hang on. 9 in the wrong spot there. So you got something like this, where you got 6 plus the negative square root of 4, and then plus 9 plus the square root of negative 25. Okay, and you may be saying, well, there's no imaginary numbers there, but I mean, there are. They're just not written yet. I mean, there are, but they're just kind of written differently. So you got square root of negative 4. Well, that's 2i. We've got 9 plus square root of 25. Well, that's 5i. And now that you've got those square roots rewritten with the I variable, then we can go back and start, adding and subtracting whatever we need to do there. So now you've got 6 plus 9 for 15. And then 2i plus 5i would be 7i. So they'll just mix in some different negative square roots and have you work through. Maybe have to do addition, you might have to do subtraction. May even have some where you might have to do a little bit of multiplication. So it may be that you may have something like this where you're doing 3 plus the square root of negative 4 times 4 plus the square root of negative 1. We're still basically doing the same thing. It's just it's complex number. It's just the square root's there instead of the I term being there. But again, still do the same thing. Square root of negative 4 would be 2i. square root of negative 1 would be 1I or just I. And then from there, we'll do our full method. So then we've got 3 times 4 for 12. 3 times I for 3I. 2I times 4 for 8I. And then 2I times I for 2I squared. All right, so the 12 is good. Again, 3I plus 8I would be 11I. Replace the I squared with negative 1 to make that negative 2. So then it's 12 minus 2, and then 10 plus 11.